Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, let's have a look at this trig question, question 8, 2013, paper 2. And you'll see if you go to your exam papers or examinations.ie that there's a note on this particular question that there was some errors in the question. Part A, a port P is directly east of a port H. To sail from H to P, a ship first sails 80 kilometers in the direction shown in the diagram to the point R before turning through an angle of 124 and sailing 110 kilometers directly to P. Okay, so the first bit of confusion here was in here and sailing, because one would assume then that R was above H if it's going to sail in this direction, but it sails more northeast if anything. But anyway, towards the point R, so that's 80 kilometers, before turning through an angle of 124 and sailing 110. Find the distance from R to HP. Okay, when you're asked to find the distance from a point to a line, always know that that has got to be perpendicular. Okay, so you are forming a right angle down there because perpendicular lines will always give you right angles. Okay, so if we draw our right angle down here and we fill in what we have, which is the 80, which is the 36, and we stick an X on what we need, then we can use right angled trig to find it for us, and it's probably the easiest way to do them all. So we have opposite side, it's opposite the angle in the question, hypotenuse, adjacent. Okay, silly old Harry caught a herring trolling off America. So which one links opposite, which is what we want, with hypotenuse, which is what we have? So it's sine. So sine of the angle equals opposite over hypotenuse, or sine of the angle equals x over 80. Bring over the 80. So x is equal to 80 sine 36 degrees. So 80 sine, just taking degrees on my calculator, yeah. So I'm getting 47.022. It doesn't say to the nearest whole number or anything. So you know what, let's put in 2 places of decimal. I always think 2 places of decimal are good if you're not asked. So 47.02 kilometers, I'd be quite sure that accept 47 kilometers in that one too. Okay, part 2 then, calculate HP, which runs along the bottom. So let me get rid of the perpendicular line I put in. So HP runs along the bottom. That's a bit thick. Okay, so again, you have a couple of ways you could do it. I could have left in the perpendicular line, okay? And I could have got the length of this part here using this triangle. I could have got the length of this one here using this triangle, because we can work out this angle here, because of course angles in a triangle add up to 180. So 36, 46, 50, 60. So he's a 20-degree angle down here. So again, I could use right angle trig here and work out this length. Adding the two together will give me the length of HP. Okay, so I could of course do that, but I am going to use the opportunity to do the cosine rule with you again. Cosine rule is great. So remember, we were saying in the last class, cosine rule or sine rule gives the same answer. I'm just after thinking I could use the sine rule as well, couldn't I? I could do those 2 sides. So you can see there's a plethora of ways to do this question, and I suppose probably led to a little bit of confusion in the exam, maybe, but there is a number of ways of doing it. I saw the cosine rule first, so let me do that one. So a squared is equal to b squared plus c squared minus 2bc cos of the angle A. If this is the side I'm solving for, then I have to use the angle across from it, okay? A and the side have to match, okay? And that's what we were doing on Tuesday. So we have a squared, or the length of HP squared if you want, is equal to 80 squared plus 110 squared plus, no, sorry, minus 2 times 80 times 110 times cos 124. Okay, all into the calculator in one fell swoop on the right because it's all just numbers. Minus 2 bracket 80 bracket 110 bracket cos 124 degrees. So I'm getting HP squared is equal to 28341.7951. Let me square root that. So square root of answer. And I'm getting HP to be equal to 168.35. And again, it didn't say how many decimal places. So let's go 2 again. Okay, so just for anybody who prefers the sine rule, I'm going to leave the right-angled trig solution to yourselves just in case that's how you went. Nothing wrong with it at all. It's just I suppose I'm presuming that you're able to do the right-angled trig. It's the same as this one, just probably a different set of sides and maybe a different trig ratio. The sine rule, okay? So very important in the sine rule that you take angle side pairs, okay? So you have to take the side that you want and the angle across from it. So I use just simple arrows to make sure that I'm doing it. I'm going to take 110 and the 36 degrees. Of course, I could take 80 and the 20 degrees either, okay? There's no need to take all of them. You only ever need 2. You definitely have to take this one because that's how you're going to work out HP. Okay, so we have HB over, so my sine rule is side over the sine of the angle across from it equals side over the sine of the angle across from it. And always remember, guys, if it's an angle you're working out, it is perfectly acceptable to write the sine rule as sine A over A is equal to sine B over B, okay? You can flip the whole thing, and it's really useful if you're using the sine rule to solve for an angle, okay? So flip the two of them. As long as you flip both sides, that is perfectly acceptable. But it's a side we need here, so I leave the side on the top. So across from sine 124 is equal to 110 over sine 36. Cross HB is equal to 110 sine of 124 degrees over sine 36 degrees. Hit the fraction button. Over sine 36. Okay, and I got 155.148, so I round that to 2 decimal places, kilometers. Okay, so slightly different. I expected it to be closer, but nonetheless, a perfectly acceptable answer. Okay, so sine rule or cosine rule, it doesn't matter which one you use. You use the one which you have enough information for. This question was unusual in the fact that you had information to use both. Okay, to explain, when I see two values like this that are outside or that far apart, sorry, I'm getting a little bit technical here now, but that's that far apart, I do wonder that the dimensions 80, 110 and this one actually form a triangle. Okay, I like to do a construction of that triangle and see, does it actually construct to be a triangle? Okay, I have a little bit of doubt and it might come back to this. Okay, so in your exam you won't do it both ways, you'll do it one way, so you'll never actually see this particular error. Okay, and I didn't actually do a right angle trig. Did anyone do a right angle trig? What do you get? Closer to which one? No, nobody did it that way. Okay. Part B. The point T is directly east of the point R. HT is equal to 110. HT. And TP is equal to 80. Okay, find RT. Okay, now this was the part that really threw people, because if I go back to the last page, you can see we have a dimension here, HR, which is 80. Okay, and one would have to assume that that's too thick. Okay, go back. One would have to assume that I can do that and call him 80. Okay, it's the same question. It's HR, okay, and it implies that it leads on from the last question. Okay, now this is what really threw people, because where is this line gone now, and so on and so forth. Okay, so the question says find RT. And just like the last part, there was a load of different ways of doing this too, which threw people. So again, it depends on what you see. Okay, I see a little triangle here. Okay, I see the cosine rule, to be honest, because I see lots of information about sides. I just need to find this little angle here. So that's the one that I'm seeing. I know that, let me go back to HR. I know that this entire angle here adds up to 36 degrees. Okay, so if I can find this piece of it, which is the inner triangle, then I can find this little bit on the outside. Yes, and I also have HP across here. Let me fill it in. 168, I'm going to go with the first answer I got, 168.35. Okay, so I have all three sides of this one. So again, I could use the cosine rule to solve for this little angle down here. Yeah, and then use the cosine rule again to solve for x. Okay, so that's how I think I'm going to go. There are other ways of doing it. So for example, you could start doing right angled trig. So you could, in theory, drop a perpendicular down here. You know he's 20 degrees, and you could work out this length. Okay, so does that make sense? Yeah, maybe I'll do it my way, and then I'll come back to the right angle trig way in case anybody prefers right angle trig. So I'm going to solve for this little angle in here, which I'm calling x, okay? So x. So angle x. So a squared is equal to b squared plus c squared minus 2bc, the cos of a. Okay, if I'm going to solve for this angle, then this has to be the side I call a. Okay, whatever side I put over here on the extreme left, I end up solving for the angle directly across from it. .68.35 cos of x. Okay, so what I'm going to do now is 80 squared minus 110 squared minus 168.35 squared. So I'm going to do that all in one go. Minus 168.35 squared. Okay, so I literally brought these over the far side and subtracted them from the 80 squared. And I am getting minus 34041.7225 equals, so the next bit I'm going to work out is what these three are. So 2 bracket 110 bracket 168.35. So I've got minus 37037 cos x for that. Okay, let's divide across by this. Okay, so we have 4041.7225 over 7 0.037. So 0.919127 is equal to cos x. Get the cos inverse of both sides. Watch them cancel, and therefore I get x, that angle, being equal to, so cos inverse of answer, 23.2 degrees. Okay, therefore, we call this little angle up here, we'll call him y. Therefore, angle y is equal to 36 degrees minus 23.2 degrees. So 36 minus 23.2 equals 12.8 degrees. Okay, so in that little triangle that I'm now going to draw in green up the top, I have a line here, and a line coming down to it here. And I have a dimension of 80, what I need to find, so that's R, T, and H. I have a dimension of 110 and an angle in here of 12.8 degrees. Okay, so let me do again the cosine rule. So a squared is equal to b squared plus c squared minus 2bc cos of a. Okay, so I'm solving for a side here and the angle across from it, so it's the x squared that has to go on this side. So it's equal to 80 squared plus 110 squared minus 2 times 80 times 110 cos 12.8 degrees. Okay, so this is a much easier version of it because I can just put the right hand side into the calculator. Cos of 12.8 degrees. So I'm getting x squared being equal to 1337.37. Let me square root the answer, and I'm getting that side to be equal to 36.57. What's that, kilometers? Okay, so that was one way of doing that question. The diagram really threw people, and it was just, I suppose, wrong. So let me just copy the diagram for us, because I just want to show you how you could do it with right angle trig if that's the way your brain thinks. You can see mine generally for I don't know what reason defaults to the cosine rule. For others it will default to right angle trig, for others it will default to the sine rule. Okay, and there isn't one better than the other. Okay, so you could drop a perpendicular here at T, and you could drop another one here at R. Okay, and the thinking being, if you get this, so we know this whole dimension here is, what was it, 168 point something, 168.35, okay? So if I could get this dimension here that I'm calling x, and I could get this dimension here that I'm calling y, then if I subtract these two, x and y, from 168, won't I get this little piece here, which of course is the same length as the dimension RT. Okay, so you can do that with right angled trig. We know that this one up here is 80. Okay, we know he's 20 degrees. Okay, so that's an easy enough right angled trig. In the same way, how do we do this one? We won't do it with that little triangle. We have to form a point up to R, don't we? And use this one. So let me just highlight that triangle to try and explain what you're going to use. Do you see that? I'm actually ignoring this line in the middle. I'm using the original HR line, which we knew was 80. Okay, and I'm using the original 36 degrees now. Okay, so now you can work out that dimension x. Okay, so I hope that makes sense. And then subtract them from 168. So again, perfectly acceptable, perfectly excellent way of doing it with right angled trig. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.